Bismillah Rahman Rahim. In this session, we will discuss permutation and combination topic from additional mathematics course for IGCSE and O-level student. In this topic, we will discuss arrangement of n distinct item, permutation of r item from n distinct item, combination of r items from n distinct item, and problem solving using permutation and combination. So these are the things that we will discuss here. Exercise 10.1, without using a calculator, find the value of each of the following using x factorial key on your calculator to check your answer. So 7 factorial means 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. So with 7 factorial may be write down as this: 7 multiplied by 6 multiplied by 5 multiplied by 4 multiplied by 3 and multiplied by 2 and then 1. So they all of these numbers are multiplied and the result is obtained as 5040. And similarly part 2, 3, 4, and this f part, f6 factorial and 3 factorial square. So 6 factorial is 6 multiplied by 5 multiplied by 4, 3 factorial, and this is 3 factorial and 3 factorial. This 3 factorial cancel this 3 factorial, and 3 factorial can be write down as 3 2 1 and 6 5 5 4 is here, and this 6 cancelled out this 3 to the 6 and this 6 5 4 the 20. Okay, now this question number 2, rewrite each of the following using factorial notation. 2 into 1, this is 2 factorial. 1 2 3 4 5 6, this is 6 factorial. 3 5 4 3. So if we multiply 2 and 1 in the numerator, denominator there would be 2 and 1, so it becomes 5 factorial upon 2 factorial. So we can write this question number 2, this part 543, this is 543, 2 into 1 in the denominator. Since we are multiplying with then 2 into 1, so we will divide with the same value, 2 into 1. This becomes 5 factorial and this is 2 factorial. So this is 17 into 16 into 15 into 14 is can be write down as 14 into 13 factorial and 13 factorial. In the denominator this becomes 17 factorial and this is 13 factorial. Similarly for this 10 into 8, and we can multiply with 7 factorial, in the denominator 7 factorial, so this becomes 10 factorial, 3 factorial and 7 factorial. This is simple. Similarly for this one, 12 into 11 into 10 into 9 into 8, and there we have 1 2 3 4, so this is 4 factorial, and here we have 7 factorial in the numerator and 7 factorial in the denominator. So if we multiply with 7 factorial in the numerator, this becomes 12 factorial, and this is 7 factorial and this is 4 factorial. So 12 factorial, 4 factorial and 7 factorial. Now question number 3, which is very important. Now rewrite each of the following using factorial notation. So n, n minus 1, n minus 2, n minus 3, and we have to write in terms of this factorial notation. So same like question number 1, question number 2. So we have to do the same as we did in question number 2. So rewrite each of the following using factorial notation. So this is given here, and we will rewrite here again. Question number 3, part A, n minus 1, n minus 2, n minus 3, and if we place n minus 4 factorial in the denominator, we will write n minus 4 factorial. This becomes n factorial, and this is n minus 4 factorial. Similarly for n, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, in the numerator we will write n minus 6 factorial, in the denominator n minus 6 factorial. So this becomes n factorial upon n minus 6 factorial. So this is n minus 2, n minus 1, n minus 2, and here we have 5 4 3 2 1. So this becomes 5 factorial. If we place n minus 3 factorial in the numerator, n minus 3 factorial in the denominator, this becomes n factorial, and this is 5 factorial n minus 3 factorial. So n factorial, 5 factorial, n minus 3 factorial. In a part D, n minus 1, n minus 2, n minus 3, n minus 4, and this is 1, 2, 3. Here we can write n minus 5 factorial, and in the denominator n minus 5 factorial. So the numerator becomes n factorial. In the denominator we have n factorial, 3 factorial, n minus 5 factorial. So this is all from exercise 3 10.1. Now in question arrangement 10.2, this is arrangement with very important topic. Suppose we have these 4 books, blue, red, orange and green. So blue, red, orange and green books are arranged. So how many ways we can arrange it? So we can place green book here, blue book here, orange book here, red books here, red books here, red books here. We can place in a different arrangement. So this book could be arranged in an order OGBR or RGBR, BRGO or whatever. There are a number of possibilities. So find the number of different ways that the 4 books can be arranged in a line. You will need to be systematic. So how many ways that there are of arrangement of 5 different books in a line. Similarly for 6 books, for 8 books, for 10 books, for 1000 books. So this is arrangement. So suppose we have 3 letters ABC. We have to arrange this letter ABC in a line. So there are possibilities that ABC, ACB, this A is here at fixed point, and we have rearranged C and B. So here we have B and AC, and similarly B is here. So C and A are interchanged. Again C, AB, and then BA. So there are 6 possibilities. So ABC can be written down. There is no other possibility of arranging this. So we can see that for 3 letters we have 6 arrangements. So there are 6 different arrangements available as shown above. So this is method number 1. For a small number of letters or items, this is easy. Method number 1 is visible and easy, but for large number of letters or items, method 1 becomes very tedious or very cumbersome. And now method number 2, similarly we have these 3 letters ABC, and for these 3 letters, the first letters, whatever A, B or C in any letter, there are 3 options. If one is placed, then the remaining have 2 options, and the last one have only 1 option. So the first letter have a possibility of 3 ways of placing, while the second letter have 2 ways of placing, and the third letter have a 1 way of placing. So it becomes 3 into 2 into 1. So the first letter can be placed in a 3 ways with either A, B or C. For each of these 3 ways of filling the first space, there are 2 ways of filling the second space, and the last one has only one place. So there are 3 into 2 into 1 ways of filling the 3 spaces. So this is 3 factorial, or write down as 3 into 2 into 1 is 6. So 3 into 2 into 1 is called the 3 factorial and can be write down as 3 factorial. Similarly for 4 books, for these 4 books, number of arrangements is given as using this method. To this, there are the first book has 4 number of ways of arranging, second book has 3 places, and so 3 number of ways can be arranged, and the second last book has 2 number of arrangements, possible ways to placed, and the last one has only 1 space. So this is 4 into 3 into 2 into 1 is 4 factorial, which is equal to 24. So there are 24 ways that these books can be arranged. Similarly, this work example, gradients. So the first number of different arrangement of these 9 letters if there are no restrictions. So if no restriction means First letter has 9 number of possibility, any one may be the first letter. The second letter has 8, and similarly the 7, 6, 3, 5, 4, 3, 2, 1. So this is 9, sorry, there are 9 letters, so there are 9 factorials for A, part A. So it will be 9 factorial. Find the number of arrangement that begins with grad. So the number begins with grad means this is fixed, and now we have this remaining 5 letters, so there are remaining 5 arrangements. So it becomes 5 factorial. And for the number of arrangement that begins with G and S, so this becomes fixed, and now we have remaining 7 letters, so this becomes 7 factorial. So the part C, the answer there arrangement is 7 factorial with these restrictions. Without restriction, with the restriction of 4 letters in the start has same, then it becomes 5 factorial. For first and last letter to be fixed at places, then it becomes 7 factorial. Similarly, for this work example, we have this 4 squares and 3 circles. Find the number of different arrangement of these 7 objects if there are no restriction. So when there is no restriction, so there is 7 factorials. Find the number of arrangement where the squares and circles alternate this way. So this square has 4 arrangements, 1, 2, 3, 4. So this is first square has 4 ways of arrangement, second square has 3 ways of arrangement, 3 places, and second square has 2 ways of arrangement, and the last one has only 1. So this is 4 factorial. Similarly, for this circles have 3 ways, then second circle has 2 ways, and the last one has 1 way. So 4 factorial and 3 factorial. So there are 4 different ways of arranging the 4 squares, and there are 3 different ways of arranging the 3 circles. So total number of possible arrangement is 4 factorial into 3 factorial, that is equivalent to 24 into 6. 4 factorial is 24 and 3 factorial is 6. On multiplication we have this 144. Find the number of circles where all the squares are together. This all squares are together. All squares are together, it becomes a single entity. So this square may be at the second place, maybe at the third place, maybe at the fourth place, maybe at the first place. So first all the squares are together. So this all 4s, the number of ways of arranging one block of 4 squares. So this 4 blocks inside is first block, first square block, second square block. This is 4 ways, this is 3 ways, 2 ways, and 1 way. So 4 blocks have arrangement with the 4 ways, and the remaining this can be placed here. If this is placed in the first place, then this it becomes 4 factorial. So if we place this in the first, suppose this block all 4 squares are placed in the first place here. If we shift it here, then it can be shifted here, it can be shifted here, this circle may be here, 2 circles, and then this block, and then all 3 circles, and then block, all circles on the left side, all circuit on the right side. So in this way, this is a single entity. So the entity becomes 1, and this entity second, and this is third, and this is fourth. So there are 4 possible ways of arranging this, and within this square there are 4 ways. Within this set there are 4 ways, and with these 3 circles, along with these 3 circles, this is also part of this is considered as a subset of these 3 circles. So this all squares may be considered as a single circle, but in that way this and this and this, so 4 ways. So this becomes 4 into 4. So the total number of possible arrangement is 4 into 4 for this condition. If the squares are together and the circles are together, find the number of arrangement where the squares are together and the circles are together. So if all squares are together, So this all squares are here and all circles are here, or this all circles may be on the left side and all squares on the right hand side. So within this square there are 4 possibilities. So this is 4 factorial, and within this circle there is 3 factorial. So 4 factorial and 3 factorial plus 3 factorial and 4 factorial. So the number of arrangements are possible as 4 factorial, 3 factorial plus 3 factorial and 4 factorial. So when we add it all, it becomes 288. This part D is very important. This question, this work example is very important. Now exercise 10.2, find the number of different arrangement, 4 people sitting in a row on a bench, 7 different books on a shelf. So four people sitting in a row on a bench is this. The first one will have 4 ways, second have 3 ways, third have 2 ways, and the last one have only 1 way. So this is 4 factorial, 7 different books on a shelf, book 1, 2, 3, 4, 5, 6, 7. The first one has 7 ways, second has 6 ways, similarly this. So there are these 7 factorials. Now different arrangement of letters. Find the number of a different arrangement of the letter in each of the following words: tiger, Olympics, and paintbrush. So tiger have 5 letters, so this is 5 factorial. Olympics has 8 letters, so this is 8 factorial, and then paintbrush has 9 letters, so this is 9 factorial. So question number 2 is very easy. This is 5 factorial, this is 8 factorial, 10 factorial. Now question number 3, find the number of different 4-digit number that can be formed using the digit 3, 5, 7, 8 without repetition. How many of these 4 digits numbers are even and greater than 8000? Find the number of different 4-digit number that can be formed using the digit 5, 3, 7, 8 without repetition. So this 4 letters have 4 possibilities. The first one have 4 possibilities, the second letter has 3 possibilities, the third letters, whatever the letter, we can pick any one. The third letter have a possibility of 2 options, and the last digit have a possibility of 1 way. So 4 ways, 3 ways, 2 ways, and 1 way. So this is 4 factorial. And how many of these 4-digit numbers are even? So for even number, this becomes constant at the last place, so this becomes have 3 factorial. For greater than 8000, then this digit 7 must be at the first place, and all the letters must be on the other places, any possibilities. So for part B, so we have for part B, for even number, this 8 must be here. So there are 3 possibilities, 2 possibility and 1 possibility. So this is 3 factorial, which is 6. Okay, there are this is the all possibility that we can see from here. And for greater than 8000, so this first place must be at the 8, and then remaining has 3 factorials. So this is 6. Question number 4. A shelf holds 7 different books. 4 of the books are crockery books and 3 of the books are history books. Find the number of ways the book can be arranged if there are no restrictions. So 7 books have no restriction, means 7 factorials is the answer. Find the number of ways the book can be arranged if the 4 cookery books are kept together. So 4 books, these cookery books, are together, and these 3 books have a different arrangement. So this all 4 books are together, so this is 4 factorial, and then these 4 books is a single pack and this 3 possibilities. So this becomes 4 factorial. So this answer would be 4 factorial and 4 factorial. So this part, find the number of ways the book can be arranged if the 4 cookery books are kept together and 3 history books may be arranged anywhere. So this is 4 cookery books and 3 history books, 7 arranged. So this is 7 factorials. And part B, 4 cookery books are together. So they are kept together. They may be placed here, these 4 cookery books, and this is 3 history books. So this may be placed here, 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 and here. So all possibilities. This has 3 and 4 factorials. So this is together. So within this they have 4 possibilities, and with arrangement of this 3 we have this 4 possibilities. So this becomes 4 factorial and 4 factorial. For arrangement of cookery books internally, 4 factorial. Arrangement of cookery books within the history books is 4 factorial, which is given here. So this possible arrangement is 4 factorial and 4 factorial. This 3 history books and this cookery books. Within this cookery books there is 4 possibilities. So this is 4 factorial, and this as a single entity with this 3 history books. So this is also treated as a single history book, and this history books 3, and this becomes 4. So this is again a 4 factorial. So this is 4 factorial into 4 factorial is 576. Now question number 4 is completed here, and now question number 5. 5-digit numbers are to be formed using a digit 2, 3, 4, 5, 6. Each digit may have only used once in an arrangement. How many different 5-digit numbers can be formed? How many of these 5-digit numbers are even? How many of these 5-digit number can be formed? How many of these 5 digits are even? So first part, there is no restriction. So this is 5 factorial, part A, and part B is even. Even means then 2 and 6 must be at the last place. So if 1 is placed at the last place, then the case may be a little different. Let's see this. Question number 4, 5 digits. We have this 2, 3, 4, 5, 6, and here for first part this is 5 factorial for even numbers. So for even numbers we have to place 2, 4, 6. 2, 4, 6 should be placed here, either 2, 4 or 6. If we place 2 here, then the remaining have a possibility of 4 factorial. So this is possible arrangements are, here we have three ways, 2, 4 or 6. This is 3, and here we have 4 factorials. So for remaining portion we have this 4 factorial. So the even number possibilities arrangement is 4 factorial into 3, because in the last place we have these 3 possibilities, 2, 4 or 6, and here we have 4 factorial. The first letter has 4 ways, second letter has 3, third letter, fourth letter, and this one of the even number is here. After that this is here. So in this arrangement we can form even numbers. So for even number and greater than 40,000, so in a C part, sorry, for number greater than 40,000, greater than 40,000, or even and greater than 40,000. So in a part C we have to find the number is greater than 40,000, means the first these 3 possibilities 4, 5, 6 may be at the first place, and the remaining may be anywhere. So for part C, this first part letter must be 4, 5 or 6, and the remaining may be whatever. possibilities. So there are 3 possibilities, 4, 5, 6, and here we have the remaining letters have 4 remaining 4 letters will have 4 ways. So 3 into 4 ways, which is again 72. And a part D, even number and is greater than 40,000. So there is a possibility of 2, 4, 6 in the last place, and possibility of 4, 5, 6 in the first place. So for this condition to be satisfied, even number plus number is greater than 40,000. So no repetition number. So in above possible arrangements, there are 7 possibilities. So 4, 5, 6, 5, 5, 6, 4. So while this 3, 2, 2, 4, 6, 4, 4. So we have this 7 possibilities. 7 possibilities. If we have 4 here, 2 here, 5 here, 2 here, 6 here, 2 here, 5 here, 4 here, 5 here, 6 here, and 6 here, 4 here, 4 here, 6 here. So we have this 7 possibilities, and this 3 have freedom, and this is 3 ways, 2 ways, and 1 way. So this is 3 factorial into 7, which is equivalent to 42. So this is very, very important part. This question is very difficult and different. If we placed 2 here, then there is a possibility of 4, 5, 6. 4, 5, 6 may be here. So 4, 5, and 6. If we place 4 here, then this 2 possibilities does not exist. If we place 4 here, then 4 and 6 means 5 and 5. And if we place 6 with 4, or 6 or 4 with 6, so this is the possibilities. So there are 7 possibilities, and the remaining 3 numbers can be arranged in any ways. So this is possible arrangement is 42. Now question number 6. Three girls and 2 boys are to be seated in a row. Find the number of different ways that this can be done if the girls and boys sits alternatively. If girls and boys sits alternatively, the girl sits at each end of the row. All girls sits at a girl sit at each end of the row. So this is the second restriction, and the third one is a girl sits together and the boy sits together. For this sits alternatively for part A. Three girls and 2 boys. So the girls are this, and if girls are this and boys are here, so girls can be sit in a 3 ways. It's 2 ways, and the last one is 1 way. Similarly for boys, the 1 way and 2 ways. So girls arrangement, possible arrangement is 3 factorial, and boys possible arrangement is 2 factorial. So this is 3 factorial into 2 factorial. 2 factorial means 2. So this is 12. So all possible arrangement is 12. The girl sits at each end of the row. So 2 girls are here, and the remaining 2 boys and 1 girl can be arranged in 3 ways, which is 3 factorial into 2. So this is these girls could be here, or the second one. So 3 possibilities are there. So this is 3 into 3. So these 3 girls, there is another girl here inside in this box. So 1 girl, 2nd girl, and the 3rd girl anywhere here. So this is the girls have 3 possibilities, and the boys and girls have now 3 possibilities. The 2 boys and 1 girl have 3 possibilities. So 3 factorial into 3 factorial. That is why this becomes 3 factorial into 3 factorial, which is 36. Now question number C, the boys and girls are sit together. So 3 girls maybe sit here, or 3 girls maybe sit here. 2 boys maybe sit here, or 2 boys maybe sit here. So this is 3 factorial, 2 factorial plus 2 factorial into 3 factorial. So this is 3 factorial, 2 factorial, 2 factorial, 3 factorial plus. So this is 12 plus 12 is 24. And now question number 7. Find the number of different arrangement of the letters in the word orange. Find the number of these arrangement that begins with the letter O. If the letter O is fixed here, then we have 5 factorial possibilities. So find the number arrangement of the letter in the word. Find the number of these arrangement that begins with the letter O. So for first part, there are 6 letters. So this is 6 factorial. And for B part, this is 5 factorial, because 1 is fixed, O is fixed here. So for the third C part, have the letter O at one ends and the letter E at the other ends. So O may be here and E may be here. So this is again, this C part here has a twist here. So we have orange and different arrangement for these 6 letters. So 6 factorials begins with O. O is fixed here. So there is the possibility of 4 ways, 5 ways. So 5 factorial. So this is 5 factorial is answer. And for O and E at the ends, so this is fixed. So this is O and E may be the 2 ways, and this is 4 factorial. So 2 into 4 factorial is 48. Question number 8. Find the number of different 6-digit number which can be made using the digit 0, 1, 2, 3, 4, 5 without repetition, assuming that a number cannot begin with 0. So number cannot begin with 0, 6-digit number has to be started. So for first possibility, 0 is not possible. Assume that the number cannot begin with 0. How many of the 6-digit number in part A are even? So this is question number part B. And for 0 to 5 numbers to form a 6-digit number, and number cannot start with 0. So this is question number D, 0 to 5, and at this place, the first 6th digit place, the most significant bit cannot be 0. So if this is not 0, so 5 arrangements exist, only 5 arrangements exist. So total possible arrangement is 5 into 5 factorial. So this is 5 factorial, and here 1 to 5 can be placed here, not 6. Only 1, 2, 3, 4, 5 may be placed here, while the remaining will be placed in a 5 factorial form, because the 1 is fixed here. So the remaining 5 digits, if suppose if 5 is placed here, then this 0 to 4 may be placed at these places. So this is 5 factorial, and similarly for 4 may be placed here, for 3 may be placed here, 2 may be placed here, 1 may be placed here, but not 0. So there are 5 ways that this digit may be placed, while the remaining digits may be placed in 5 factorial ways. So this is 5 into 5 factorial for this condition to satisfy that this most significant cannot be 0. This is equal to answer 600. Now the B part, we have that the B part, let's see it again. How many of the 6-digit number in part A are even? The part B, in question number part B, the numbers are even. So there is a 0, 2, 4 may be placed here. There are 3 ways, and this is have a 4 ways here, because this is 3 ways and this has remaining has 4 ways, and this is the remaining 4 letters will have this 4 factorial ways, because D naught cannot be 0. So D naught cannot be 0 here, so there is a 5 factorial. And for D naught, when D naught is equals to 0, there are 5 factorial. If this is equals to 0, then there are 5 possibilities. When D1 is not equals to 0, then there have 2 into 4 factorial into 4 ways. So which is 192. So if we place 0 here, then the remaining 5 can be placed in a 5 factorial way. If we place 2 here, 2 or 4 here, then these 2 possibilities is this, and here we have 4 ways. The remaining 4 digits may be placed here, and while the other remaining 4, this is 1 digit placed here, 1 digit placed here, and the remaining 4 digits are placed in a 4 factorial ways. So this is the possibilities. So the total possible arrangement is 5 factorial and 2 into 4 factorial into 4, which is 302. Now question number 9. 6 girls and 2 boys are to be seated in a row. Find the number of ways that this can be done if 2 boys must have exactly 4 girls seated between them. 6 girls and 2 boys are to be seated in a row. 6 girls and 2 boys. 6 girls and 2 boys are there. If 2 boys must have exactly 4 girls seated between them. Between 2 boys, exactly 4 girls are seated. Between 2 boys, 4 girls are to be seated in this arrangement. So for this case, 4 girls sits together in a 4 factorial ways, and side girls arrangement, the side girls arrangement in a this 2 girls and any one of the girls. So this is 3 factorials, and the boys arrangements are in 2 factorial, that is 2. So the total arrangement is 4 factorial into 3 factorial into 2, which is 288. This is also very important part. Now in the next session we will discuss 10.3, which is permutation.